mixed family farm. We're 20 k's west of Kimber, a mixture of clay reds and sandy loams. Property here is more of a Mallee, traditional Mallee dune swale system. 330mm rainfall, mixed cropping and sheep. We've had this property for 5 years now. It's been a fairly well established seep when we came, but we have seen it extend probably 50% in size, particularly on the back of the 2016 wetter season. It takes up around 3 to 5 hectares of area now. It's a total salt scald. So this particular seep, we've fenced off around a 20 hectare area, which we'll put into permanent livestock production. We've sown down lucerne around the remaining area of the site. We've planted out some puccinelia, some salt tolerant grasses on the scald itself. We've planted some trees, some river red gums that are taken off quite well, and we're actually just installed a shallow bore system where we intend to remove water pump into a reticulating tank on the hill to meet our livestock needs. When we assessed this site, we dug down, we found water to a depth of at least 3 metres, and the water itself was around 2,000 parts per million, which is well within livestock drinking range, with quite good recharge from what we could see from digging the hole. So we made the decision to put in the shallow bore. To do that, we brought in an excavator and excavated an area around 4 metres by 4 metres round and about 2 metres deep. We lined that with geofab, and we installed it was an old fish farm pipe around 600mm across. We drilled a series of holes into that pipe to let the water infiltrate, and then we backfilled the main hole with rocks to allow the filtration and a better recharge rate of that bore. And we've since put the solar pump on top, and our intention is to pump it up to a reticulating tank on top of the hill, where we've got the ability to shandy with mains water should we find a problem with the salt rising. But we're pretty confident that there's enough water here that we should be able to make quite good with it, and we'll assess that over time as to whether we look to irrigate some crops down the path.
We can see when we've looked at this site, there's a big catchment. A lot of the water from the whole catchment flows down through this zone where it's presenting as a scald in the surface, and we've used NDVI mapping to satellite images to really show that, and that's helped. So while we've got the sump and the pump, it's really important. You can't just dig an open dam and pump the water out, because that water becomes degraded very quickly. So you need to build a proper lined covered sump to maintain that quality, and that's what we've done here. We've just done some water measurements around this site, and it's very interesting where we're taking the water from at a proper sump out of the ground up there. It was about 2.23, 2.4 decisiemens per metre, which relates to around 1,500 or 1,600 parts per million, which is quite fresh. But interestingly, down the bottom end of this seep area, it measured about, it was quite black in colour, and it was around 8 decisiemens, or which is more around your 5,000 to 6,000 parts per million. So again, it just shows that in terms of the management of these, and when we're trying to extract the water, it's good to know the water quality, because if we're going to use it for stock feed, make sure we take it from the top end where it's going to be fresher, and also then it's got more chance of lowering the water table of this whole area, so we can start to bring this back. The pump at that site is a solar pump, and initially we were hoping to have pumping a lot of water up to a tank up there. Unfortunately, the farmers just had to change it to a slightly stronger pump to be able to get the height to the tank, so that then he can start feeding his livestock that water. But there was a period he put the firefighter on and put 5,000 litres up there in in a day, and that certainly did quite significantly drop a number of these piezometers that we've got through this site. So that's the hope. If that's sustained and he can keep pumping that out, then hopefully we can start to see a change in this seep area and start rehabilitating it back to full production. So here we are at the tank at the top of the hill, and it's got monitors on there so we can measure how much water is going in. It's also got a salinity meter on it as well, so we can keep an eye on that as well. And so it's from this tank then that the farmer will be able to use initially for livestock water, which will be very handy for him. But if we find that there's so much water available, then the consideration for some irrigation may happen in the future.
So looking at the results of pumping in February, 5,000 litres, March, 3,300 litres, and April, 4,000 litres. We can see that at each time at the Sump piezometer, it's dropped the water level by about 40 centimetres, but within generally 2 to 3 weeks, we can see that at this catchment that it's refilled quite quickly. So that's after a fairly wet spring as well. So it basically shows that to have an impact on draining the water table out, there's got to be a lot more pumping, a lot more often for a sustained result. And this is also seen in the piezometer that is 80 metres further down in the catchment. And while we can see that, after the wet spring, it has started to dry out a bit, but each time the pumping happened, it dropped the water table by 10 to 20 centimetres there. But with the water coming in and also the rains that have followed, those water levels have regained again. So what can we learn from this trial? Certainly that you can use seep water to pump it out and use it for stock. Make sure it's good quality, and that the seep water table can be lowered, but it refilled very quickly, so a lot more pumping would need to be taken out to get there. And the setup costs for this construction gear and is around $15,000. And that must be assessed against the farmer's cost for water, in this case about $3.50 per 1,000 litres, but also the restoration that it's helping of the land back to 4 hectares back to cropping, hopefully eventually, but certainly pasture in the short term. So this has been a good trial to show that there are innovative ways of using the water to help overcome seep situations, but we haven't quite got it to the stage where we're having a permanent impact on reducing the water table.